We left off the last video in running a workflow that was already established and saved in our workflow browser. This was performed on a pair of FastQGZ reads, which were from Illumina paired end sequencing of a bacterial isolate of Streptococcus pneumoniae. And here we have the results of that analysis. And just a quick review, you'll see that if we scroll through the history on the right-hand side, we'll see some things that are green, which means they were run successfully. A number of items that were red, which I had expected to fail, that is from our annotation step using Proca. And then a couple steps on the right in blue, which are paused because the preceding steps have failed it. So we can go through each one of the steps in the pipeline. If you recall, 1 and 2 are the input data sets, 3 and 4 are from Trimmomatic. And if we click on this link, we can see a couple different things here. It'll populate this little window below it. And you'll see a number of different pieces of information here. One is the size of the file, 121 megabytes. Information about the commands that were run. And that it was basically, if you were trying to reproduce this on command line, those are the commands that you would run to replicate the analysis that we just did. And at the bottom is a peek of what the data file looks like. And as you can see, it's a FASTQ file with our customary FASTQ header, the read, and then some metadata about that read that includes its quality score per base and quality score for the entire read length. We can also hit a number of different pieces of information here. The little floppy disk button here will save or download the data to either your computer or a drive you have attached to it. This info button that we'll go ahead and click here will provide you more information about the step that was run. And then these little double arrows here will be to run the job again, which we'll use in a second. So if we look at the information here, we can see the input file, the size of it, the tool that was run on it, Trimmomatic, the inputs for this, which were the forward and reverse read, the commands that were used in command line to run Trimmomatic, and how long the job took. And again, a little bit of the information on what the file looks like. If we continue on, we see that there's FastQC run on both the trimmed forward and reverse reads. In a separate video, I'll go a little more in detail with what this analysis looks like and how you can use it to triage your reads. But if we want to click on it quickly, we can use this little eye icon here. And there's a number of valuable information in here, which are all hyperlinked to the left. This is actually an HTML file, which you can download, again, using this save button right here, and then open in your browser to analyze the performance of your quality of trimming, and then also look at some information about the reads themselves. And again, we'll spend a separate video looking more in detail on assessing the output from FastQC. So those two steps perform satisfactorily. Last, we have the GFA file, which is the assembly graph from the de novo assembly that was created using Unicycler, and then also the FASTA file. So this is your assembly. And if we click the drop down, we'll see that there's 85 sequences in here. So our spades run that was optimized using Unicycler produced 85 contigs. And you can get an idea of what the FASTA file looks like. So this one's actually small enough where we can look at the data and see what the FASTA file looks like. So if we click this eye arrow, we'll see the output from what spades is. Here we have this arrow designating the start of a read. Read 1, the length of it, so this is 262,000 bases at a depth of 1x. And that's going to be our first contig in there, which is, when you think of a 2.1 megabase genome or so, a pretty big chunk of DNA there. So this annotation could, or this assembly could be downloaded, again, using this button, or we could export it to a separate folder. And we'll talk about that in a little bit more, but basically that's one of the steps that failed right here. If we look at it, we can see that it basically wasn't able to write to the place that I was interested in submitting it to. And that can be changed and rerun, which we won't go into detail. The main thing I wanted to talk about is the Proca step failing. So we can see everything in here is red. That means that Proca was unable to run. And if we click on it, you see it says error, and we kind of see a peek at this error. So if we click this, this little bug over here, it says view or report this error. When we click on it, we can see this error in this black box right here. Tool generated the following standard error. Table 2 ASN, the copy of Table 2 ASN is more than a year old. This is actually a comedically common problem with Proca because it uses this NCBI tool that likes to expire every year. So everyone has to update their installation of this program on an annual basis, and it just happens that we ran into that experience here and could use it as an example of how to restart the analysis. So if this was something where you really thought this is an error on the side of Galaxy that the RC help can be able to address, then you could go down here and type a message and just say like, please update blah, 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 which I've already done, report it, and they will assess the error and determine whether it was a user mistake or whether it was something that needs to be updated in the system. And then you would just click the report button and that would get sent. Now, I know that this has been updated, so one of the things I can do is say, okay, well, I know the program's working correctly now, right now. How do I restart it and then continue on with the rest of my pipeline? And the way to do that is with this little double arrows right here. So if you click on this, it says run job again. It'll pull up those parameters that you set in the when you ran the workflow originally. We're not going to change anything here. You can see that everything's the same as before. Scroll down to the end and then hit execute. And now we can see that this is gray, meaning that the job is pending. It's about to start. And then once this runs, it'll actually pick back up at this point here and run the things that were proceeding this step in the workflow. And in a moment, we should probably see this change from gray to yellow as it starts to run. And hopefully that everything will complete satisfactorily and we can reanalyze the data that is output from this step. So I'll stop here, and the next time we'll pick up, we can look at a FASTQ C file and how to talk about how to assess the read diagnostics.